Okay, now we start recording, and first of all, in this section, I want to talk about how to make a grid, just how to make a grid. A strong grid is very important. So basic rule is like a geometry class, high school or a middle school geometry class. If we have a toolbox, if you connect this corner at this point and also this point, if you connect them both, if this is a two perfect square, then I know it seems not, this one is not in the center, but in theory, this one need to be in the center. Must something wrong with my box itself. I think this is a little wider. Need to be a little wider. So if this is a two perfect box, this point need to be the center. Doesn't make sense. This point need to be the center. Okay, let me try again. I am so very sorry. So if we have a two perfect square, if we connect this point, then this two corner and have a diagonal, and then this point. If this is a two square with the same edge, this point should be resting in the middle of this line. So if we think backwards, and if we already have one box, one grid, and then if we're gonna draw a grid in a perspective, and then how we define the second grid, where it gonna go? So we go the same thing. We connect the corner point here, and also connect the middle point on this line. On the other side, corner point will be on this side, and then on the other side, there's a line. You find the middle point, and you draw a straight line. If this one goes all the way, go back, and it will safe to say this will be the second grid. Okay, this line is a little, need to adjust a little. I am sorry. So it will be somewhere here. It will be somewhere here. I hope it makes sense. And I always make mistakes sometimes, so I do. So don't worry if you make a mistake. So this is the middle point. I think this one would be better. So that is how to find another second grid. So the reason we talk about the geometry, because once you define a perspective, you want to find a perspective. If you want to draw a plane, like whatever plane you want to draw, a plane like this, and that two lines are converging to the back somewhere to make sure your line is always exaggerating. And also we have this line front already. If you want to do another line, make sure these two are converging. And then if the project you are drawing, you need to find you need to make a, let's say 2x3 grid. If it's a mouse, yeah, there's a chance. Let's quickly draw a footing over the mouse. So a mouse usually have a 2x3 grid. If you look from the top, it will be something like this. That is the mouse. So let's keep that in mind. Let's draw a mouse. And also from the side view, it will be something like this. That will be the mouse. So that's a mouse. So regardless as a 2x3 grid. So you already have everything kind of converging. If it's 2-point perspective, it's converging to the both sides. And then let's find the central plane because it's 2x3. So you need to define the central plane first. So when you define the central point, so the bottom lines, you divided this line evenly. But since this corner is close to us, so you can exaggerate a little, kind of moving upward, moving towards this direction a little. So then we draw another line, but when you're drawing, just make sure it's converging to somewhere else, And also make sure those lines kind of evenly converging to some point. You do not want to do this. If you do this, this two lines will meet first. So the grid, once you got the grid wrong, and then eventually, there's a chance to form, finally the object you constructed will go a little off. So just estimate like a little estimation to make sure they go evenly with the same speed, the same pace. So that's why this one about the right. And then we do need to estimate the first grid. Let's say the first grid probably somewhere here. How we define it? Because this is close to us, this corner is close to us, so this line is supposed to be a little wider, little longer than this one, right? Because this edge is close to us, so this one is a little longer. And why this is longer again? Because in this case, this plane, we choose this surface, this plane, the front. We saw more front plane, so this one will seem that everything from this angle will be a little longer. Oh, hold on a second, I need to stop. I need to stop my vacuum cleaner. Okay, I come back. My vacuum cleaner started working, so I had to stop it. So now we're gonna use this basic geometry theory here. And so we need to find we already have this corner point. If we define a middle point here, and it goes the same if you want to find the middle point. This middle point, it will be converging to somewhere else, some point with the rest of the line. So if you connect this one, and let's imagine this is the middle point, you connect this one, and I would say this will be the second grid. This will be the second grid. This will be the second grid. So if this is the middle point, we already defined that this is a middle line between these two, and then this will be another middle point on this edge. If you want to do a perfect grid, that's how you're going to do it. So it will be somewhere here. Somewhere here. So from this point, go to here, here, and make a relatively accurate 2x3 grid. 2x3 grid. And like I explained before, why this line kind of much longer than this one? Because in this case, we see a lot of top front plane. We see this plane more, and this one, this edge on the side being condensed. Be condensed or compressed. So we see this more, and it's supposed to be this one need to be longer, but it just we happen to choose this perspective. And if we want to draw another plane, it's just the same thing. It's really define the first line, how you decide how much plane you wanna look. Or like this one, let's do the grid again. We find the middle point, and we define the first plane, and then find the middle point. Find the middle point. You don't have to do this grid things every time, but now it's something like this. For this grid, you don't have to do this, use those diagonal middle point, define diagonal middle point. If you want, you can do that, but later when you get used to that, you just need to estimate. You just need to estimate a little. Usually I would always define the kind of basically 2 points that structure first. What that means is if you want to lower your eye level, which means you're not going to see too much top plane. Let's try those kind of grid. Lower your eye level, lower your eye level. So everything kind of, can you see the difference? This one is we see a lot of top plane. And this one, we kind of lower our eye level. If eye level for this box will be here, and then I would say the eye level, it will be much close. When your eye level is very low, close the top surface, then you'll only be able to see a flat line, right? If the eye level is close to exactly same level as your eyes, so then that plane will be a straight line. So if it's you're looking at something much lower, and then you're able to see that top plane. So that's what it means. If you squeeze the box you constructed, and then which means you are lower your eye level. It's really so when you're starting drawing, we need to think that how to pick an optimal angle. How to pick an optimal angle. If there's a lot of things going on the side, and then you probably want to squeeze the top plane, and then we get a chance to see what's happening on both sides. If there's a lot of things going on for that object on the top, then you probably would choose the angle you would see more top plane. So how you started is very important. You make it more flat, see more top plane, or kind of squeeze them and condense, make it more condensed. So for this grid, usually I would recommend always kind of define the whole plane first, and make sure they're converging to the both side. And then you still the same method. In this case, you need to exaggerate a lot. Like I defined this one as a middle point. You can tell this one is much longer than this because it's kind of like a more extreme angle. So we exaggerate a lot. And also when we define the first grid, if it's still 2 by 3, the first grid, let's say if the first grid is here, because we still see a lot of side view when I draw it here. And if that is the first grid, then find the middle point. Let's exaggerate a little. Let me draw the middle line first. Okay, this is the middle line. So that will be the second grid. And this will be the second grid. Let me take a look. This is the corner point. This is the middle point. Let's do it again. And this will be the third grid. So at the beginning, I construct a plane. Use 4 lines to construct a plane. Now we find this grid. It's 2 by 3 grid in this perspective. So both, this is the first. So always construct a plane first, and then you define the grid if it'll help you to construct form. So I hope you also noticed that in this case, you need to think about when you define the grid, you need to think, optimal angle. If you want the top plane, a little small top plane, or like a very slim top plane, which means if you're starting to draw something like this, which means you would see a lot of side view because the top plane kind of slim. So which means you would see a lot of side view. If you draw a top plane like this one, and then this whole thing will become something like this. Okay, I feel this is a perfect explanation. So that is when you try to construct a top plane, use that original 4 lines, and then you would keep that in mind, what kind of angle you need, because you can define your own angle. And once you have this plane, and then you structure structure the grid. The grid is basically depend on what kind of items you want to draw. So I hope it explains the different angle and how to construct a grid and also optimal angle. And also when you construct a structure and keep rotating different orientation, like this one I make sure the object kind of facing this side. When I study the second one, I'll make sure to kind of have a different orientation. It will make your final drawing just looks nice. And then I change the orientation again, make it more interesting. You know, when you try to use explain the object in a three-dimensional way, so it's just a different keep changing the orientation. So that's very important. And also different project, we use a different method to construct them. If you want to construct a hair dryer, let's say hair dryer, and then you probably need a cylinder. And also for this hair dryer, and you can see this two line converging a lot. So this angle is a little, you can define those lines. It's kind of, so the angle is a little extreme. So it's distorted. It's a little distorted. Is that possible? Yeah, from some angles that's possible. So it's really based on how you construct them, how you pick an angle. So that's the angle I picked. It's kind of distorted. So this angle is coming down all the way. It's, and also I would encourage you to draw all those invisible lines. It helps us to check the perspective, check all the perspective to see if we are kind of have all those lines converging together. So those invisible lines help us to check all the line we have, if it's converging at the same pace to some point. And that is, so if you want to start to structure a handle, that's what you're going to do. You extend this line, extend this line. Usually when you draw a straight line, I usually would ask to kind of rotate your paper. So that will be much easier. But I try to, if I rotate the paper too much, you probably will feel dizzy. So I try to keep the same direction, same orientation. And see, I told you I made a mistake too. So it's normal. You just need to keep practicing. And then we got another base. But what if you said the handle is kind of need to be a little smaller? It's the box need to be a little smaller. Then please do this. You get this diagonal first, and if it's a little smaller, you get this diagonal. Then you're trying to find, okay, you reduce the size. And this line need a parallel to this one. This line need a parallel to this one. This need a parallel to this one. This is do the same thing, parallel to this one. Okay, now you had a little smaller structure. I hope it makes sense. Little smaller structure. Or if you want to say for this, when we construct this hair dryer, and the front plane is smaller, what if the back plane it's not a complete box style? It need to be a little bigger than this one. It's kind of taped a little. If it's taped, it goes the same method. You have a diagonal first, then you extend this line, and you have those diagonal. Because if the space extend, this diagonal should be the same. Should be the same, right? So you use the same diagonal, extend them, and then you got a this plane. It's the same plane, you just extend those lines, and also extend this line. just make sure they are all share the same, so diagonal lines here. And that is about the, if you want to find the central plane of this hair dryer, did I say hair dryer? Oh, yes. That it will be the central plane. It's kind of taped. So that will be the central plane. And then if you want to study, define a ellipse, all the ellipse, eventually, all the ellipse, if without a perspective drawing, all the ellipse, eventually it's a circle. It's a circle. And they have 4 points that reach the edge of the box. And also, that theory I explained it before. If you draw a two diagonal, and okay, it's a geometry class again. Geometry class again. If this is the length is 1, this is a 1, and this is a 1, this is a 1. They're all the same length, like half of the edge. So if this is a 1, let me think about that. The length of this line would be 1.414 if I didn't mistaken. What can I say? Because it's basically, okay, I'm not gonna continue this math class because I forgot. All I can remember is kind of square root. Is that a 1.4.1? You figure that out. So if this is a 1.414 and we just estimate, you can draw a circle and estimate, you would feel like this is a third in. If the diameter, it's like kind of a third in. Per third in, or you can say the radius here, it's kind of a third in the diagonal of this box, this small box. So the same thing if you want to draw a ellipse in draw ellipse. Draw a ellipse here. Since we have this, I call it 8 points method. 8 points method. This is the 1/3 in. This is the 1/3 in. This is the 1/3 in, and then we also have the reference, 4 reference points. So we have this diagonal first, then you will find the middle point. So it will be very safe to use a diagonal, find the middle, central point, This line and just estimate. It happened, my estimation is kind of perfectly lined up with that diagonal here. So once you have this middle point, you kind of estimate where the another line goes, And so we already have 1, 2, 3, 4, 4 points. 1, 2, 3, 4, 4 points. So, and then 1/3 in, 1/3 in, 1/3 in of this line, 1/3 in of this line, 1/3 in, 1/3 in, 1/3 in, and you can tell okay, this is 1/3 supposed to be somewhere here because this line is very, very long, so we need to estimate here. I would say it's safe, it's somewhere here. I want to erase this to make it clear. I told you I'll make mistakes, so don't worry if you did too. So if this is a 1/3, and you can almost see this ellipse. So you just need carefully to connect them. When you connect them, use a very line line to connect them. And I would say that is about the shape if we put a perspective like this. And like I said, this is the center plane line, this is center plane line. Later, you just need to connecting them, seal this surface, and later connecting this line to the back. So that's how you construct the front of this hairdryer. And of course, all the hairdryer, the material itself has some thickness, and then you probably need to draw the thickness for this hairdryer. And like I said, you need to turn your page if it's easy for you to drawing. So we probably need to turn the page to find a position you're most comfortable with. And hold on a second, I need to stop the recording again. Okay, I resume this recording. And what else? Okay, if there's something else in front of this hairdryer, and then all you need to do just draw another box, extend, because sometimes those designs it happen to be there's something in front of the this top plane, the front plane, probably would have another shape. It's something like this, and then all you need to do just connect those dots. You still have those corner. I hope it makes sense. Do you notice I still use a box, kind of extend, find the middle point, extend, and then the front. That will be the front of the hairdryer. So it's kind of, I hope you can see the shape. And I still use those guidelines. Though I didn't exactly draw all the line, but you can tell when I draw, I kind of use all those vanishing point, the reference point to extrude that the front, because that happens a lot. It's something like this. So that is the front of the hairdryer and how to construct them. And also, okay, I kind of get excited about this. Okay, and also like the handle, we can do it very quickly to, let's assume there's some areas you have a cut at the top, and then this is the handle coming down, and you would also find, eventually probably will find that is a cross section of the handle. But I don't want to go too deep of the how to find the two pieces connect together, maybe in another class. Otherwise it will go very long. And why I draw a circle like this, because the top plane is something like this. Since this one is close to us, this plane is further away. So the degree of ellipse is supposed to, if it's close to us, if eye level is here, this plane ellipse is a straight line. And when it's further away, the plane is kind of, the degree open up, and the close away and open up more. And here it's kind of open up more. So that is, I'm sorry, I keep saying sorry. And that is another plane. So that's how you draw a cylinder, because it's close to you, so it's the degree is smaller. So you're just aware that is all estimation. So to me, I understand the degree here is something like this. So for the handle, if you want to draw a cross section, if you want a profile line or a construction line or contour line, okay, contour line probably a better word. Contour line. So that is how it goes. Or the contour line here will be something like this. So basically it's all based on the same structure. All right. So that is use to box or cylinder to construct something with two simple geometry form, and like a hairdryer. It has something here horizontal and another piece vertically meets them together. And I said that's also very important to find how those two pieces, those joints, how it joined together. Okay, I can't help to say that, because simply put, the lowest point will be somewhere here, and the highest point will be somewhere here. Let's estimate a little, and it will be somewhere here, and then you just need to connecting all those invisible lines, imaginably connecting them, but that's another story. The joints will be something like this, something like this, something like this. So all you need to do is just define this lowest 2 point, and also when this plane rising up, we define this 2 point to connect them. So, but angle, if the angle is different orientation, these curves will kind of acting differently. But that is basically how what it looks like for the joints. Okay, and not all the drawings need a box. If we want to draw a pentagon, if we want to draw a pentagon, we still need to understand what a pentagon exactly looks like. If we want to draw a pentagon in perspective, what a pentagon looks like in, for the top plane or front plane. And if you Google pentagons, that's what I did. Since I want to explain in my class how to draw a pentagon, I Google a little. Then I figured it's kind of if you use a half circle, you divide it into 4 sections. Use 3 points divided into 4. Then you find a third line here. And also this half circle, you divide it into 3. And then you find this one here. You find this one here, a third. Then we got this point. We got a quarter point. And also, let's connect it with this. It's almost a pentagon. It feels like I eyeball the structure. I don't know if it's science, but it's almost something like this. It seems accurate. So you just need to find a diameter. Because it's a circle, so any diameter is fine. You can just define your own, just make sure it's kind of perpendicular to each other in a space. But what kind of angle? Basically, I would say any angle is fine, because how you get an ellipse? Because you have a box. So because you have some box like this, so you get this ellipse. So, and also any diameter, in reality, all the diameter around this ellipse should be the same, because it's a circle. It's just a circle. It happened to be a circle in perspective, so any line should be fine. So you define a perpendicular diameter first, and then if you want to draw a what is that? Pentagon. That's how you draw a pentagon. I hope I'm recording. I didn't know. Okay. That is a quarter line, and this is a third, and find this one first, find this one first, and find this line, find this line. So that is a pentagon in perspective. Pentagon. Though it seems kind of all those lines, this line is very short, this is very long, because again, that is a perspective, because we choose this plane, this diameter, we choose a plane like this. We see a lot of the front plane. We see a front plane. We see a front plane a lot. So this line became extremely long, and also the same thing go to that direction. This will be seems very long, and this line being condensed, kind of, or you can see distorted. I don't know if it's the same meaning, but it's condensed a lot. This is very long and this condensed a little, but this is just because it's further away, So that is a pentagon in what? Pentagon in perspective. And the same thing goes here. You can do the same. So the method is you find a top plane to exactly without any perspective. And if you look at this and what's the proportion with that? And then you just need to figure out a way to put in the perspective. This line is supposed to parallel with this one, then go to this one too. And then you're connecting this one, connecting this point, connecting this one, I guess. So that's another pentagon. Just another pentagon in perspective. So when you draw a chair, you need to use this. So that's how we use a reference point to define, or reference point, reference line to define the form. And I want to quickly explain on the corner, not all the drawing, all the design, we need to use a grid. We need to use a grid. For some of them, we use a spine. Is that spine? How to spell that? Spine, I guess. We use a central line. Let's say if you draw a Vanda mix have the cup. And let's say this is a cup. Maybe I put a cup, and it happened to be this is the direction I choose. This is the angle I choose. It's kind of slanted to the right. And that will be the main axis of the cup. Let's say this is a cup, and this is the angle I picked. If you want to draw a handle, I would highly recommend use a spine line. And let's say if we will draw the handle will come all the way here. For the handle and the spout, it's always rest in the opposite direction. Will be resting in the opposite direction. If this is the spine of the handle, and then the spout will be somewhere here. We go to the spout later. We talk about it here. So that's why it will be nice to have a diameter first. This is a diameter, another diameter perpendicular to each other. So we find this one. You will find this useful. That's why we need this diameter. And this is how it goes. Why is the handle is not parallel this one? Because we need enough space to hold the handle, right? We need enough space between these two. So if the cup taped down goes that direction, this spine line need to give it enough space. So then you just need to extend. Let's say this will be something like this. And we need to also understand how this handle connecting with this cup. Okay, let's do this first. You extend, and then go down. That two lines kind of converging with the cup because you're trying to find that cross section, connecting the handle and the cup. So if that's a cross section, you probably will be something like this, right? This is the central line, and we extend. So we already find this cross section. And then this is the corner of the handle. How you draw, when you draw this line, to make sure it's kind of curved to that direction, because that handle is always curved, it's not straight. Why this is not like this or that? Because this curve kind of need to follow the same perspective angle or follow the same curve. If you look at the top view of the Vanda mix, you would see the handle, those curves always curved in, follow the direction like this. So if you want to draw a handle here, then you need to follow the curve here. That's how you draw those corner lines here. When you extend, you need to have a direction, sense of direction. And when you draw another section line here, because a handle usually is something like this. It's something like this. It will get bigger in the middle. That's the handle, usually what it looks like, right? It looks like something like this. So that's why we need to define this cross section. So now we are doing this. We are define this point. We use spine. It's still on rest on the central line, and we use this one and extend, extend, extend. When you extend, make sure this one looks longer. This point kind of shorter. This side need to be longer, and then where is this center point? Okay, now we are going to do a guideline to help us find where the center point were located. This is the middle point, it's rest on the spine, and then you draw another line, it kind of goes to the vanishing point, because this is supposed to all those lines supposed to go the same vanishing point for this plane. For this plane, it's supposed to go to the same vanishing point. And also this corner is supposed to point to the center of the circle, right? So that is how it definitely will be somewhere here. So let's imagine in this case, let's say it will be somewhere here. Okay, hold on a second. Hold on a second. So this is the central point. So now that is a plane. That is a plane. So you have this plane here, you have this plane, and then we just kind of need imaginary connecting them, also connecting them. And in this case, you need to connect it here. Okay, it just happened the angle I picked it here, you cannot see how it's bent over, but you definitely can see this plane, how we connected them. You can see only a little. We cannot see too much of this plane. It just happened to be the angle I picked. And so the same thing goes. Okay. Can I pick something else? If I the angle, if I draw another plane, and let's quickly find extend this line, and okay. Forget about the Vandermex, because right now I kind of draw another handle. It's not exactly the same like the Vandermex, but that's how we construct a form, use a spine. And if this lines, let's say, did I use the same direction? I just want to show you what it looks like if we are able to see a little side. Okay, in this case, now I think once we connect all of them, we can see the side of the handle. And this is the top plane, how we connected them. For the handle I draw here, now I still use the same plane. I hope it makes sense to you. And now we finally able to see the side, what it will look like. That is the side. So this is the top surface, and that is looks like from the side. That is also for the top surface, probably it will bend over. So you probably want to cut this edge, make it rounded coming down. And then that is another plane. So you just need to shade it a little, let people feel how those forms kind of angled in the space. So that is the side of it, how to draw a handle, use a spine line. This is how to draw a handle using spine line. And also for the spot, that's the same. Find this, this is the middle point, extend, and find the cross section. And you don't have to use those heavy lines. I just want to make it clear to you. So this spot need to go that direction. And for all the spot, it's always taped on the front. So you just extend a little because it's needed taped to the front. And that's how it kind of looks like in the space. And of course, later you need to add the thickness of the spot, and the spot, or the thickness of the spot. So that's how you have a handle and a spot opening, because they are always resting in the opposite direction of the cup. Okay, I think it covers.